Hey everyone, this is Mr. Higgins, and here's Notes H, Exponents. So I encourage you to just watch the video first, and then you can go back and pause it and copy things that you need to copy. And even as you're watching it, pause it when you need to soak something in or rewind when you need to rehear it. Alright, so let's start with a positive exponent of positive 4. 2 to the positive 4 is 2 times itself 4 times. It's not 2 times 4. It's 4 2's multiplied together, which gives us 16. If it's a negative exponent, it's not a negative number. It means it goes in the denominator as 1 over 2 to the positive 4. So it moves across the fraction bar, and the negative exponent becomes positive. And then it's 1 over 2 to the 4, which we just did, is 16, so 1 over 16. In x form, it might just look like this, x to the negative 4, so you write it as 1 over x to the 4th, and that's pretty much it. All right, let's check out when to add exponents. And that's when the whole terms are multiplying. 2 to the 4th, 2 to the 2nd rather, times 2 to the 4th. So there's 2 2's multiplying. Now there's 4 2's multiplying. So altogether there's 6 2's multiplying. It makes sense that you would add the exponents. And 2 to the 6th is 64 when you multiply 2 by itself 6 times. Now it could be an x form like this, and again you just add the exponents, x to the 6th. That's it. There we go. All right, let's check out another example where negative exponents are involved, but it's the same rule. You still just add those exponents, 2 and negative 6. So 2 and negative 6, those two add to, let's see, 2 and negative 6. They're different signs, so we subtract and get 4 and take the sign of the bigger number. So it's a negative 4. 2 and negative 6 make negative 4. And there's another negative exponent, which just means it goes in the denominator as 2 to the positive 4, or 1 over 16, like we saw before. In x form, it's the same kind of thing. Add the exponents, get x to the negative 4th, and then write it as 1 over x to the positive 4. So kind of the same thing with x's. Let's look at when to subtract exponents. We do that when the terms, one moment, that'll come back in focus. There it is. When the terms are being divided, so if you have 2 6's, or rather 6 2's multiplying, and you divide it by 2 2's multiplying, those 2 of those 2's cancel with 2 of these 2's, leaving 4. So I'll go over that more in class, but in a nutshell, you subtract exponents, 6 minus 2, and you get the 4. And then 2 to the 4th you work out. You get 16. In x form, same kind of thing. You just subtract the exponents, get x to the 4th, and that's it. All right, here with some negative exponents, it's the same rule. You just have to remember how to subtract, like negative 6 minus negative 8. It's always top minus bottom, by the way. Negative 6 minus negative 8 is tricky. That minus a negative 8 turns into a plus positive 8, or plus 8, or just 2. So that's why the exponent is just 2. Yeah, 2 to the 2nd power is 4. And then in the x side of things, same thing. Negative 6 minus negative 8 is 2, and then you just end there if there's an x. That's as far as you can go until you know what x is. All right, when to multiply exponents is when you have this situation. So you have 2 2's multiplying. Oh, but that's happening 3 times. You know, like if you have 2 chores to do, and you have to repeat all the chores 3 times, that's 6 chores altogether. You know, we'll look at that more in class too. But you basically just multiply the 2 and the 3 and get 2 to the 6th. Bam. You can work it out, of course. 2 times 2 times 2 times 2 times 2 times 2. You get 64. All right. In the x world here, same thing. You multiply exponents and you get the same 6, x to the 6th. All right, if we have a negative exponent, it's the same rule. You still multiply the exponents, negative 2 times 3. So you'll get 2 to the negative 6. And this is the first thing we covered in the first section. That's 1 over 2 to the positive 6, or 1 over 64. That's tricky. Here it is again with x's. You multiply the exponents, and you get with 2 times negative 3, or negative 2 times 3, negative 6, and that's the same as 1 over x to the 6th, like that. All right, one more example. Here, both exponents are negative, but it works out because we're multiplying exponents, so it becomes positive. 3 to the positive 4, or good old 81. Yeah, same thing over here. or the negative exponents, any exponents like this, multiply, in this case, to a positive 4. All right, I hope that helped you do exponents, the worksheet for homework. Make sure you get these notes down as well. And in case you're curious, students or parents, if you're watching, I want to show you the rest of the notes that we've done this year. And you can see if your student is on top of it or not. So notes A, that's different for every student. I had them take a multiplication assessment, and the ones they got wrong, they copied in this section. So this should be full of the ones just that your student got wrong when we did it in the beginning of the year. Notes B, I just wanted to share with the students on the side that, because I'm a physics teacher as well, that they exert a gravitational force on everything in the universe, and that's a fact. And then this example or two when we were able to throw in squares, and that's how it links to squares. If you get 8 times closer to an object, you pull on it 64 times as much, for example. So that was just on the side, but it helped us practice our multiplication tables a tad. All right, note C. Let's go through this a little quicker. Reducing fractions, or fraction basics, starts with reducing fractions, goes into converting to a mixed number, and then ends with converting from a mixed number back to an improper fraction. All right, then we did notes D, which looked at, here it comes, this was factors and multiples. So we looked at factors and found a greatest common factor. We looked at multiples and then found the least common multiple. Okay, so great if you're checking that your son or daughter has these in their notes section and having them copy it down if they don't. All right, notes E, combining integers. This is just good old adding and subtracting integers and multiplying and dividing integers. And here we went through all the cases, all the rules that there are pretty much the ones that are circled. Okay, and then with examples, of course. So that was that day, or that week. Then we did, more lately, decimal and fraction conversions, where we start with either a decimal and convert to a fraction, or where the numbering is on this side, we started with a fraction and converted back to a decimal. This is a tricky case, converting a repeating decimal to a fraction. This we just tested on today, as a matter of fact. And then one more example there with another repeating fraction. This continued on the back where we were converting a fraction to a decimal, and the way to convert these fractions to decimals was by long dividing. So we did a quick review on long division. Let me show this a little better. That, and that is what we covered. All right. These last ones were super quick because I want the students to memorize 1/3 is 0.3 repeating and 2/3 is 0.6 repeating, like you're seeing on the left side there. All right, that brings us to our latest notes. Well, not counting H, which you just wrote down, but G, rational and irrational numbers. We also put this on today's test. So just differentiating between the two types, examples of rational numbers and how you write them as a fraction, and examples of irrational numbers which cannot be written as a fraction. Yeah, then a little bit of this, approximating square roots. And that summarizes it right there. But yeah, we have this little chart at the bottom so students could figure out, say, root 29 would be right between 5 and 6, but closer to 5. Yeah, and then these were filled out on another version, 81 and 100, of course. All right, I hope that helped. Students, complete your notes, and parents, see what we're doing.